Hello, welcome to the tall building projects. This is the problem statement by Skyfi Labs. I will show you how to make this project in ETAP software. Open the ETAP software. This is the evaluation version of ETAPs. Now open a new project. Set all the data as shown. Then click OK. Give the number of grid line in X and Y direction, that is 4. And spacing of grid in X and Y direction, that is 6. Number of stories is 23. And the typical story height and bottom story height is 3. Custom data story, then edit data story. You will see that the master story is set to 23, but we need to change all. From story 1 to story 8, the story 8 is the master story, so change it. And change the similar story to story 8. Then from story 9 to 14, set the master story as 14 and similar story as story 14. Then first from story 15 to story 19, the master story is story 19 as mentioned in the problem. Now change the similar story to story 19 in each case. From story 20 to 23, it is already 23, so no need to change it. Click on OK. Then click on grid only, then click on OK. The building is created and you can see in both the views, plan view and 3D view. Then click on define material properties and add new material. Change the region to India, material type to concrete, standard to Indian, grade to M40. Then OK. Then click on OK. Add new material again, set as rebar, then HOST 500, then OK. OK again. Add new material again, change the material to mild grade to 50, then OK again. Click on OK again to exit. Define section properties, click frame section. Here we have to add new properties for column and beams. So click on add new property. Click on concrete rectangular. Give the name of property, column 500 into 500. Give the depth as 500 and width 500 also. Modify show rebar, then set to column, change the rebar materials as shown. Then click on OK. Click on OK again. Add a copy of property. Give the name of the property as column 550 into 550. Change the dimensions and materials. To M40. Then change the dimensions to 550 Then click on modify show rebar. The properties are same, so no need to change. OK. Then click on OK again. I have committed a mistake here, so I have to modify the property and change the material to M40. Then OK. Then add a copy of property. Give another column size, column 600 into 400. Then material M40. Depth and width are 600 by 600. So as it is the copy of the previous column, so the properties are same, so no need to change. Click on OK. Then click on add new property. Then auto select list. Give the property name as auto select column. Auto select design type as concrete. Then select all the columns list and add. Then click on OK. Then give a new property of beam 500 by 300. Change the material to M40. Give the dimensions as shown. Then click on modify show rebar. Then change to beam and change the rebar material. The cover is set to 25 mm each. Then click on OK. Click on OK again. Add a copy of property. Give the property name as beam 550 by 350. As it is the copy of the property, so we need to change only dimensions. Everything is as same, then click on OK. Then add new property for a new beam 600 by 400. Change the dimensions. Then click on OK. Add a new property. Click on auto select list. Give the name as auto select beam. Change the material type concrete. Then select all the beam list, then add. Then click on OK. Then click on OK to exit. Then click on define section properties, then slab sections. Add new slab sections. Give it is a name slab 150. The thickness is 150 mm. Then click on OK. Click on OK to exit. Then move to the story 1 by arrow keys. Then change the story to all stories. Select quick draw columns, then check out the properties auto select column, then draw the columns where required. Click on auto draw beam, select the property, then draw the beams. Select draw slabs, check the property, draw the slabs. Then move to the story number 5. Move to the story number 9. Click on draw columns, check the property and draw the columns. Select the area very carefully, then click on quick draw beams, draw the beams, then click on quick draw slabs, draw the slabs as well. Move to the story number 15. Then click on draw columns, draw all the columns, then select the beam, draw beams. Selection might be very careful, so select very carefully. Select all the beams, then select quick draw slabs, draw the slabs as well. Then move to the story number 20. As 20 to 23 is similar, you can go to any of the story from 20 to 23. Draw columns, here I choose one story and draw columns, beams and slabs. As it is similar to 21, 22, 23 story, so I select it and click on replicate. Then click on story. Then select story 21 to 23 as it is similar. Then click on apply. Click on OK. You can see just move up in the list and see beams, columns and slabs have been drawn in 21, 22, 23 stories. Move to the story 1. Select as all stories. Select the slabs carefully. Verify the slab selected. Click on assign, shell loads and uniform. Give the uniform load 2, then click on apply and OK. For all the stories, the dead load has been applied. Then by changing the stories to similar stories, select all the shells. Verify the shells below. Then click on assign, shell loads and uniform. Change the load button to live. Give the live load as given in the question, that is 5. Click on apply and OK. Then move to the upper stories. Story 9. Select all the shells by clicking on select. Now select all the shells. Click on assign shell loads, then uniform. Change the load as 4, then click on apply, then OK. Then move to the upper stories that are similar. Move to the story number 15. Select all the shells carefully. Click on assign shell loads, uniform, and change the load, that is 4. Click on apply and OK. Then move to the story number 20. Select the shells. Click on assign frame shell loads, uniform, then load 3.5. Click on apply and OK. The load has been applied. Then move to the topmost story, that is story number 23. Select all the outer frames in story 1. Select very carefully as we have to select only frames. Then click on assign frame loads and distribute it. Give the load as 0.2. Click on apply and OK. As you can see, the load has been applied. Move to the upper stories. In story 9, in the similar way, we have to select the outer frames. Keep the selection as similar stories, then select the outer frames. You can verify the selection in the bottom. 72 frames selected. Click on assign. Click on frame loads and distributed. Give the load. As 0.2. Click on apply and OK. Move to the upper stories to story number 15. Now select the outer shells. Select the outer frames. You can see 60 frames have been selected. Click on assign, click on frame loads and distributed. Give the load 0.2, click on apply and OK. Move to the upper stories to story number 20. Select the outer frames. Click on assign, frame loads, distributed. Give the loads. As 0.2, apply and OK. And select one story. Select the outer frames. As we have no cladding on the top of the building, so click on assign, frame loads, distributed and select delete existing load. Click on apply and OK. Then select the story as one story. Select all the joints and select fixed restraint. Click on apply and OK. The joints have been created on the base of the building. Click on draw, auto cladding, click on use floors, then OK. The cladding has been drawn automatically. Here the geometric design is being completed. Click on define, click on load patterns, add wind load. Select the type of load, select the code, that is Indian IS 875. Click on add new load. The load has been added. Then click modify lateral load. Then according to code book, we have to select all this data. As we are designing for the Bangalore city, the wind speed for the Bangalore city is 33 as per code. So give the data 33. Terrain category as per code three. Select 3 and the structure class is C in the IS code. Risk coefficient is 1 and the topography factor is 1 in IS code. Then the exposure height, top story is story 23, so no need to change it. Click on OK. Click on OK to exit. Click on elevation view and A. OK. Select all stories. Then select all the cladding has been selected. Click on assign shell loads, then wind pressure coefficient as mentioned in the code book, that is plus 0.8. Click on windward, apply and OK. The windward load has been applied. You can see where the load is acting by rotating the building. Click on elevation, click on B, then OK. Here the load is also acting, so we have to put the windward load. Click on assign shell loads, wind pressure coefficient, give it as 0.8. Click on apply and OK. Then click on plan, click on story 1, then OK. You can see the windward load has been applied. Then click on elevation, click on D and OK. To apply opposite direction wind load, that is 0.25. Select all the claddings, click on assign shell loads, wind pressure coefficient, give the coefficient as minus 0.25. It is leeward, so click on leeward, apply and OK. The load has been applied. Click on elevation and click on C and OK. Here also the load is been acting, so select all the claddings, click on shells, windward coefficient, the coefficient is same, click on apply, OK. Click on elevation again. Click on 1. OK. Select all the claddings. Move to the upper elevation. Select all this. Elevation view 3. Select all this. Then again move to the elevation view 4. Then select all. Click on assign shell loads and wind pressure coefficient. Give it as 0.8, which is negative value. Click on apply and OK. The load has been applied. Click on plan. Move to the story 1. OK. Here you can see every load has been applied. Move to the upper stories. And see how the load has been applied. You can check on every stories. In this way you can check how the load has been applied. So all the wind loads have been applied. Next, click on use extruded view, and the frame's extruded view is been shown. Click on analyze, run analysis. Give the file name and save if you haven't saved before. Then click on save. It has been saved. Now the analysis is on the way. You can see below. You can see the undeformed shape of the building. And check the displacement by moving the cursor. Then click on design concrete frame and start design or check. It will take some time. As you can see, the design is in progress. So wait for a while. (706) concrete frame is failing. So click on yes. We have given the auto select column and beam list. From that list, which is suitable section, the software will automatically assign the sections to the building. Now there is no warning. The building is now correct. Click on verify all members passed. Here see, all members has been verified and passed. Now in this version of the detailing, there is no detailing. So click on calculate, reverse scheduling. Here it is showing this is not available in this version. As this is not a licensed version, this is a evaluation version, so detailing is not available in this version of eTabs. So here is the report of the project. Here is the summary report. From this we can see every data of each members in the building. Every beam and column data has been given here. We can know the details of the project. This is the main project report. It will take some time to load. It is the project report. Every details of each members is here. Here you can see the reinforcement in the 3D view by zooming in. So as given by Skyfi Labs, I have completed the assignment. This is the video which I made for my certificate purpose. Thank you.